Hello, welcome to our presentation, MTUncertainty, assessing the need for post-editing of machine translation output by fine-tuning OpenAI large language models. It is a collaborative work between Logos Global in United States and University of Manchester Natural Language Processing Group in UK. Logos Global was led by Serge, Gleb, Irina, and from Manchester side is me and Goran. This presentation and our paper is going to be published in European Association of Machine Translation 2024 in Sheffield. We have our QR code. You can download our paper for more details. Machine translation post-editing is a standard process now in the industry for productivity solutions. Hallucinations, incorrect terminology, factual and accuracy errors, either small or large, as well as many other types of errors, are inevitably to varying degrees of extent. And the error rate is never zero with neural models. However, even with those languages that are not handled by machine translation very well, there is still a significant portion of segments which are not changed after human review. This portion varies from 10% to 70% in some cases, according to Logos Global statistics. The question is it possible to use AI methods to mark these segments as requiring less effort and let human revisers focus on those segments that need attention instead? So the motivation of this work, we have a list. Translation quality evaluation is an essential step of a modern translation production process. How good or bad are current large language models on translation quality evaluation without seeing the reference? Can we formulate this as a binary prediction task on machine translation uncertainty if post-editing is needed? Furthermore, does the size of large language models matter? Does language pair matter? And does the text domain matters on such tasks? Here is our investigation pipeline. We use ERP data with commercial machine translation engine, followed with post-editing. We will arrive with historical post-editing data, and we fit into the OpenAI API model for fine-tuning, and then we test the machine translation output. The task definition and setup. We took data from past 8 language projects from ERP content translation. Since the content was a non-SAP, but ERP content, we use the STH-MT engine and raw STH output, then further post-edited. The data for the project consists of source English, translated proposals, and the final high-quality post-edited output. We fine-tuned one of the OpenAI models for the classification task. And furthermore, in our second part of investigation, we fine-tuned 2 more of OpenAI models with different size. Note that here we didn't do prompt engineering. Instead, we did a fine-tuning using our prepared dataset. For methodology, we took OpenAI models with Curie, DaVinci, and the GPT 3.5 with 13 billion, 175 billion, and 175 billion parameters, respectively. The 8 language pairs we investigate, including English to Italian, German, French, Japanese, Dutch, Portuguese, Turkish, and Chinese. The historical post-editing data we have are from Enterprise Resource Planning, ERP content translation. using an MT engine to translate the source into 8 languages, followed by post-editing. Furthermore, to investigate the different sides of the training and testing influence on this task, we took English-Japanese news domain data with training testing size from 2K, 4K, 6K, and testing size 400, 800, and 1200 bytes. We took 3,000 lines of bilingual data and split it into training and testing for the first experiment. Since average size is about 17 words of sentence, the training data contained about 35K words of source data, 35K words of machine translation, output, and post-editing. In the first step, we took English-Italian and English-German as our experiments. We have examples of this data from source English from United States and machine translation output and post-editing from Italian and also German. We draw confusion matrix, including false positive, false negative labels, and we detail them in our paper. Here is Italian and German. In the diagonal from top left to bottom right corner, you can see that most of the predictions are correct. In the opposite diagonal, the error predictions are much smaller portion than the correct prediction. This also applies to English-Italian. And to compare the model size from Curie to DaVinci and the GPT 3.5, we list the parameters here. We can see that Curie only have 12 layers, while DaVinci and GPT-3 have 24 layers and 175 layers, respectively. And the parameters increase from 13 billion Curie model to 175 billion of other two models. However, what we can see is that the correct prediction ratio is very identical, do not change much across these three models. Also, the error prediction in the opposite diagonal. And to investigate how models, how training, fine-tuning size matters for this task, we take a news domain English to Japanese data set to carry out a comparison with training size increasing from 2,000 to 6,000 K and test set from 400 to 1,200 K. And the total number is 2,400 to 7,200. Here we can see that the false negative portion is slightly higher than false positive portion, which ranges from 12% to 20% and 2% to 10%. Some of the conclusion is that the first and foremost finding we found is that the model actually learned enough information to make a very significant prediction of whether the segment has to be added or not. And we also listed some solutions in our paper how to deal with this situation in an industrial setting. Either leave the either we call it leave as it is, LAI, or it is possible that for concrete language pairs and machine translation engine, the portion of LAI segments will decrease with the size of training data and further fine-tuning. If LAI segments are excluded from a human loop and go straight into publication is one solution. And another solution is all LAI segments are marked as 100% empty matched in a CAT tool. In this scenario, the total error rate for final content will be 7.9% for Italian and 11% for German. The saving on post-editing volume would be 30% for Italian and 63.8% for German. And we have formulated the calculation mathematical formulas in our paper. For our future research directions, we intend to run this experiment for more languages as long as we can get this training site. We intend to explore to what extent the model can absorb data for several languages and how prediction will change. We are also interested in seeing whether the model can continue learning as fit with more consecutive chunks of data for the same language. We have a nice poster at the EAMT 2024. Please come to our poster if you come to the conference. Once again, here is our paper, MTUncertainty, assessing the need for post-editing of machine translation output by fine-tuning OpenAI LLMs. And we have QR code. You can read our paper details, and we look forward to hear from you about your feedback and comments. Thanks again for the attention, and I need to say that Serge contributed a lot to this PPT preparation, and I just revised it. Okay, that's all. Thank you.